STEM science. One question that comes up is how do we measure distances to objects, celestial objects, whether it's stars or galaxies that are far away from us, if we just simply cannot just sort of drive out there or fly out there and sort of measure it based on some sort of measuring device, how long it takes there and how fast it takes for us to get there, because the distances are so large that we simply cannot do that. So how can we measure distances to objects that are very far away? One way that we can do this is through something called parallax. Now, it's something that we're all familiar with, but it can also help us sort of understand and recognize just how far things are away from us based on how things shift when we have a change in perspective. And we've all seen this. This really comes about if you ever look at an object that is in front of another object. So right now, this red ball in front of the door there in the background. And if you were to look at this ball through one eye, you might see this ball lined up perfectly like that. Now, if you close that eye and open up the other one, you might see a bit of a shift, like so. This is called parallax. So if we were to really simplify what parallax is and how it can help us determine the distance of objects that are far away, if we look at objects and compare how they shift against a more distant background, objects that are closer up to us will shift more against the background compared to objects that are further away. An example. Using the same example here, I've got the ball really close up. This is a star, let's say. And I'm looking at it through my right eye right now. And what I'm going to do is I'm going to close my right eye and open up my left eye. And this is what I get. You can see there just how much of a shift. The right eye, that ball was right in the middle of the door, and with my left eye now open and my right eye closed, you can see that it is just cutting into the door. All right, same example. I've got my right eye now open, left eye closed, and you can see I've got the ball sort of further away, an arm's length, and it's fit right perfectly in the door. Now I'm going to close my right eye and open up my left eye. And there it is. And you can see that the ball has shifted, but not as much as when the ball or the star was up closer. So using mathematics and using something called triangulation, we can actually estimate how far away this object is based upon how much it shifts against that background. Let's do one more final example. And you can see here I've placed the ball or the star quite far away, and I've got it right dead center. You can even have to look at it in terms of where it is on that black chart paper behind it. And this is with my right eye open, left eye closed. Now I'm going to close my right eye, open my left eye. And there it is. And you can see it just shifted just ever so slightly. This, with the mathematics behind it and the use of triangulation, we'd be able to determine that, yeah, that star is much farther away than the other stars that we saw earlier. So how can we apply this to actual use in trying to determine the distance of stars that are far away? Well, we're going to use some high-powered, very sensitive telescopes, and what we're going to do is we're going to take a look at a distant star and see how it shifts against a background of other stars. And instead of us simply closing our left eye and our right eye, we're going to use the position of the Earth as it revolves around the sun. So at one point, we are going to take a look up at that star and note the background that is behind it. And then 6 months later, when the Earth is basically on the other side of our star or our sun, we're going to take a look at that star again and see how it has shifted. And using parallax and mathematics and triangulation, we are going to be able to estimate just how far away that star is. And that, in a really brief nutshell, is triangulation. Now, just to let you know, it is limited to stars or objects that are basically within 1,000 light years distance from us. So it's not great for really, really far distant objects because we can go for millions of light years away from us, and we're seeing light from those kinds of distances. We're not able to use triangulation to help us, or parallax to help us try to figure out how far those objects are. So there is a limitation here. But basically, that's how parallax helps us determine the distance of some of these faraway objects.